Thank you for that, Lisa. So my name's Matthew, and I'm going to go over some ways in which a particular computer program could be used in a maths classroom. Now, the program we're looking at is called Logo, and it's been around for quite a long time. But I certainly feel that it meets the criteria that Lisa was just talking about regarding technology, and there's certainly a lot of research into its benefits. Some of which includes that it's very engaging for children, it helps visual learners, it can certainly meet the needs of EAL children, and it meets the requirements in the NGSS. Now, what I'd like to do is I want you to imagine you're teaching a grade 6 class and you're investigating the angles in regular polygons. And the children would be familiar with the names of shapes, regular shapes, and also what their internal angles were. So this is what Logo looks like. As we can see in the middle of the screen, there's an arrowhead, which we call a turtle, and we make it move around by giving it commands. So you can make it do left or right turns. Let's do a left turn, and you put the number of degrees in to do that. And let's go forward again. And what I would do to begin with is I would just let the children play with that for a while. The commands are on the left-hand side here, just so they get familiar with it. Now, if they make a mess of everything, my favorite command is CS, and you can go back to the beginning. Now, the first thing I'd ask the children to do is to draw a square. So we go forward, and then we do a right turn, 90 degrees, forward again, the same amount, and we do another right turn. And here we go. We have a square. Okay, so they shouldn't find that too difficult, hopefully. Now, the next thing I'd like them to do, which is more of a challenge, is to draw an equilateral triangle. Now, most likely what will happen is if you ask the children to do that, as they would know that the internal angle of an equilateral triangle is 60 degrees, they will do something like this. Okay, so right turn 60 and forward 10. And they'll be a bit confused to begin with. Why does that not look like an equilateral triangle? And then hopefully they'll work out for themselves that they were looking at the internal angle when they should have been looking at the external angle or the angle of turn. So if they work that out, which they may need some support with that, they will be able to draw an equilateral triangle. Here we go. Something. So it'd be 120 degrees, not 60, and forward 10. And the confusion there is caused as well because the internal and external angle of the square are the same. They're both 90, whereas with any other regular polygon, it's different. So what I would do after that is I would ask the children to investigate some other regular polygons, perhaps pentagons, hexagons, and any shape that can be divided by 360 degrees without a remainder. And then I would ask the children to tabulate that data. So let's have a look at what that might look like. So here we can see in the table here so we've got the number of sides, and they can put this data into the table. And I would hope that they would be able to look for some patterns after that. So they may see, for example, that the sum of the internal angles increases by 180 each time, that the internal and external angles add up to 180 degrees, and then you may ask them to look for some equations or some general rules. And again, we're doing this inductively. The children are using the data to find this for themselves. So, for example, the equation for the external angle of a regular polygon is 360 divided by the number of sides. The sum of the internal angles is slightly harder. That would be a number of sides minus 2 multiplied by 180. And the internal angle, again, is slightly trickier. So if they couldn't find it this way, perhaps they could explain it in words. Okay, so, I've used Logo many times with many different groups of children. I think it's very engaging for them. They have a lot of fun with it, and I'd highly recommend it. So I'm going to pass over to Imani now, and she's going to be looking at another practical demonstration of technology in the classroom. So thank you for listening.